Hello, everybody. So from today, we start chapter 4, reactions in aqueous solution. So as you may know, many reactions, chemical reactions, take place in solution. For example, typically, we add one solution from one beaker to another beaker, and the reaction happens. So in this chapter, we will cover the ions in aqueous solution, and we will introduce different type of chemical reactions and show some how to work with solution, and very importantly, we'll do some quantitative analysis. So, sorry, okay, I forgot. So let's, okay, presentation mode. So first, I would like to review some knowledge we learned in the chapter 1. You know, when we talk about matter is composed of the mixture and the pure substance. And then there are two kinds of mixtures we introduced. One's called homogeneous, and another is called heterogeneous. I hope you still remember that. So, what is heterogeneous and homogeneous? So maybe I can use this iClicker. Of course, we will not do iClicker by remote mode. I will tell you the answer. You see, there are two mixtures. So the first one, as you can see, the cobalt hydroxide is here, but the solvents is there. They are not really uniform. So in this case, we see this mixture is heterogeneous. And on the contrary, this one, the potassium chromate. If you look at everywhere, they are orange color. They are uniform. So this is a homogeneous mixture, according to the definition. So the B is correct answer. In other words, so the heterogeneous mixture is a mixture that is not uniform throughout. This is what we learned, right? Yeah. Like the picture here shows, they're not uniform. Here and here it's not the same. Here you mainly only have water, but here you do have the cobalt hydroxide. So for the homogeneous mixture, like potassium chromate, yeah, it's everywhere it's the same. Okay. In this chapter, we will introduce a lot of terms. Yes, it seems boring for you, but it's important that you know them so you can discuss something with other chemists. So first, a solution is a homogeneous mixture. That means for a solution, everywhere is uniform. And the solution consists of two parts. One's called a solute and one's solvent. So the solution contains this part dissolved in a solvent. So this brings us to another two terms. Solute is a substance that dissolved in a medium to form a solution, like the previous one, like the potassium chromate. Yeah. And the solvent is a medium where the solute is dissolved. It's a medium. I can give you one example. For example, if you add some salt, which means sodium chloride, into the water, and then you shake it and they become a solution. In that case, the solute will be the salt from the kitchen, from your kitchen item salt, that is solute. And water is a medium that your salt is dissolved. So water is solvent in this case. Also, you often see this word in this course, yeah, like aqueous solution. So aqueous solution means we use water as the solvent. Very often we use AQ mean aqueous solution. Like the potassium chloride, dissolve into the water. So a solid, for example, compound may dissolve in a solvent, water, excuse me, and dissociate into ions. We use these words. Dissociate means separate into ions. For example, the sodium chloride is a salt we eat in every day, can found in the kitchen. So dissolve in the water, that will give the sodium ions and the chloride ions. But sometimes a solid may not dissociate into ion, but they stay together as a molecule. For example, ethanol. Ethanol is an alcohol. It's soluble in water, but when it dissolves in water, it remains together as a whole molecule in the solution. The molecules, they do not dissociate into ions, or only very little partially, not completely dissolve. Dissociate, not completely dissociate. So, okay, another two terms, and electrolyte. Electrolyte is a substance that conducts electricity when dissolved in water. Again, I use sodium chloride because every day we see it. If we dissolve this one, that salty water can conduct electricity. Another one is a non-electrolyte substance that does not conduct electricity when dissolved in the water. The reason that one does not conduct electricity because they remain in the molecular form. The electrolyte can conduct electricity because they dissociate into ions. And we know ions carry charge, either positive and negative. This is why the electrolyte conduct electricity. Okay, I will show you some videos. For electrolyte, there are strong electrolyte, weak electrolyte.
A strong electrolyte is a compound that ionizes completely in solution. Hydrogen chloride breaks into hydrogen and chlorine ions.
You see, this is a strong electrolyte. They completely, I think completely is an important word, dissociate into ions in water. Here we can use chemical equation to describe this process. Like, okay, the HCl and dissolve in the water, and then it is dissociated in the two types of ions. So let's take a look at the weak electrolyte. The weak electrolyte only dissociate partially into ions, which means some molecules still remain in the molecular form. Let's watch this video.
A weak electrolyte is a compound that only partially ionizes in solution. Some hydrogen ions dissociate from acetic acid molecules, but others may rebond at the same time.
As the video shows, there are many molecules, you see only one, dissociate into ions, and then sometimes they also recombine with hydrogen, form the molecule again. This is why when we use equation, we use this double arrow. Double arrows mean reversible. That means reaction can go in this direction. Also, this process can go to another direction. So the reaction is reversible. The last one is called a non-electrolyte. non-electrolyte from the language, you can see it even does not dissociate into ions, not partially.
Some compounds that dissolve in water, such as ethanol, do not dissociate into ions at all. Such compounds are called non-electrolytes.
Yeah, when dissolved in the water, the ethanol or the alcohol exists as molecules, not ions. This is why this one does not conduct electricity, because in the solution, there's no ions exist. So, okay, the solution are conductive. You will do one lab about the conductivity of the compound. So this slide is important. The solution are conductive because their ions dissociate in the solution. It's ions that conduct electricity. So the higher the concentration of the ions in solution, the greater the conductance of the electricity. So this introduces apparatus for determining the conductance of electricity. Actually, this is a very simple setup. You even can do it by yourself. If you buy a battery from a supermarket and a couple of wires and conductive wires and two electrodes, that electrode you can use graphite, or you can simply take a piece of copper, for example, or other metals like silver. And then you have a bulb. A bulb connect here. Then here, if you add strong electrolyte, you will see this light will be bright. But if you put some non-electrolyte, like we talked about previously, there's no ions in the solution, so this one will keep dark. And if we put some weak electrolyte, like vinegar, and this one is a little bit bright, yeah, close to dark. So this is tell you the same things like before. We just use. This is a real setup. Yeah, this is a picture. Yeah. In reality, we can two wires and the electrolyte, and we have the wire circuit. We cannot see them. Yeah. So you see, for the strong electrolyte would be very bright, and the weak electrolyte will be like that. And the non-electrolyte here, then the bulb will be dark because there's no electricity to drive them. Yeah. Bright. So strong, weak, and non-electrolyte. Again, okay, unfortunately, in this virtual class, we cannot do so many. In class, I click, but I will tell you the answer again. So the answer will be, this one will be, which one is which electrolyte, strong, weak, or none? This one must be strong electrolyte, this one must be weak, and this one is non-electrolyte. So D is correct answer. Okay, so from this slide, we talk about the water as a solvent. Water is a very popular solvent. Many solutions are made from water. It's not only because water is readily available, it's cheap. It's also more importantly, is because water is a very good solvent for ionic compound. Because water is polar. Okay, we did not introduce the polarity yet, but here just let you know. And the oxygen has higher electron-activity. That means oxygen tend to attract more electrons compared with the hydrogen. In other words, more electrons will be on the oxygen than on hydrogen. So This is called polar. I think you can understand this level. It's okay. We will talk about that in the later future chapters. So, for example, if we have this sodium chloride and this solid mean this S means solid. If we put it into the water, okay, it dissociates into the sodium and chloride ions. So when the ions dissolved from the solid crystal, is completely surrounded by the water molecules. So this is called hydrated or salted. Okay, this is solid sodium chloride, for example, and when dissolved in the water, you can see this is a positive charged sodium, and then water will use a negative charged oxygen. The polar, yeah, negative. It's not a negative charge, but I mean the negative part of the water, because water have to have the one part is electronless and one part is electron rich. The electron rich part will towards this positive ion. For the negative ions, the hydrogen, the electron less part will be pointed to this negative charged ion. This makes the water very good solvent for the ionic compound, because the water molecule can keep the ions in solution very stable, not recombine and form the precipitate. We'll talk about it later. Okay, I hope this is a video I can play.
An ionic solid dissolves in water because of its polar nature. Notice how water molecules become attached to the ions of a sodium chloride crystal in the process called hydration. Positively charged sodium ions attract the partial negative charge of the oxygen in water. A similar attraction occurs between negatively charged chloride ions and the hydrogen atoms, which have a partial positive charge. These interactions loosen the attractions between the ions in the crystal, dislodging them from the crystal. Additional water molecules surround the released ions, insulating them from attraction to other ions.
Yeah, I think this is a very good video. Yeah.
An ionic solid dissolves in water because of its polar nature. Notice how water molecules become attached to the ions of a sodium chloride crystal in the process called hydration. Positively charged sodium ions attract the partial negative charge of the oxygen in water. A similar attraction occurs between negatively charged chloride ions and the hydrogen atoms, which have a partial positive charge. These interactions loosen the attractions between the ions in the crystal, dislodging them from the crystal. Additional water molecules surround the released ions, insulating them from attraction to other ions.
Okay, very good. So this brings up another concept, the solubility. Because in your daily life, you can see if we add some salt into the water, it dissolves. But if we continue to add a lot of salt in the water, you will find some salt stay on the bottom of your beaker. They will not continually be dissolved. The reason is because there's a maximum amount of the solid that can be dissolved in a given quantity of the solvents at a specific temperature. We mention the temperature is because in most of cases, when you increase the temperature, the solubility will increase. That means more solid can be dissolved. Okay, we use some state symbols. Here, one is AQ. AQ means ionic compound that dissolve in the water. In this chapter, also often see S after the compound. That means that compound is insoluble in the water. That means if we put that compound into the water, they will remain in the solid form. This is why we use S. And sometimes, for some chemical reaction, there's some water formed. The product is water. So in that case, we use L. Yeah, we just use L. Yeah. I think it comes from the liquid. And another one is gas. If you have a reaction, produce some carbon dioxide or oxygen, for example, gas, then we use that state symbol to indicate this gas. So from now, we're talking about the most difficult part, challenging part in this chapter, but it's also very important. Because if we do not know the solubility of some compound, any compound, it's difficult for us to know, to predict if one reaction will really happen or not. So let's first take a look at the solubility rules. And then we will talk about the precipitation reaction. So to predict if one compound, ionic compound, is soluble or not, then if I were you, I will first look at the cation of the compound. For example, this first rule tells us most alkali metal salt are soluble. That means the group 1, the Roman numeral number 1 on your table I gave to you. So alkali metal group 1 salt are soluble. The example is the group 1 including lithium, right, sodium, like potassium. If you see the sodium chloride or whatever it is about the ion, doesn't matter. As long as you see the sodium is alkali metal. It's a group 1 metal. That one will be soluble. There's no doubt. Similarly, if you see a potassium, okay, it's also alkali metal, okay, that compound is soluble. So that's easy. And so the B rule said ammonium salt are also soluble. Okay, so that is friendly. As long as you see ammonia, you can clearly make a judgment it's soluble. Okay, so the first rule is very useful, very important. Keep in your mind the group 1 elements and ammonia, when they form the ionic compound, they are all soluble. Then afterward, I will look at the ion of the compound. Yeah, so first, the most nitrate ions, or bicarbonate ions, chloride ions, and acetate ions, and perchloric ions, they are soluble. Okay, but among of these, I think most, if you forget all of them, but at least you should remember nitrate. Yeah, I highly recommend you memorize this nitrate because it's it's very popular ions. The second rule said most halide salt are soluble, but they are conditional. Yeah, there are some exceptions. We say most halide salt are soluble. For example, the copper chloride, the sodium chloride, the cobalt chloride, they're all soluble. However, if these halide ions meet these 4 ions, they will form insoluble compound. Especially ask you to pay attention to this silver and mercury. Yeah. So I also suggest you take out your table, periodic table, and mark these 4 elements to see where that 4 elements located. So for sulfate, similar, most sulfate salt are soluble. That means when you see sulfate, the first things come to your mind should be most of them are soluble. Yeah. However, you should pay attention. They have some exceptions to more exception, except for this one. If sulfate, like sulfate, silver, sulfate, lead, and we have 3 more. exceptions. Let's read again. Most sulfate are soluble except for this. That tells us the barium sulfate is insoluble. It's not soluble because sulfate salt are soluble, but the barium is an exception. Also, calcium is an exception. That means calcium sulfate is also not soluble. Okay, the D rule said most salt containing phosphate, carbonate, and chrome sulfide ions are insoluble, except for those containing alkali metal ions and ammonia. You may remember in the first two rules, we talk about the alkali metal and the ammonia ions. They are soluble unconditional. They are absolutely soluble. This is why this become an exception for this, because these ions are insoluble. Of course, when they combine with this, they are soluble. Yeah, we talk about that. These alkali metal and ammonia, they are always soluble. So there's no exception. Yeah, even with this kind of ion, they are also soluble. But except for these ions, those ions, when they form the ionic compound, the compound is insoluble. And another rule said most hydroxide salt are insoluble, except for these hydroxide ions meet this one. Yeah, except for example, again, alkali metal, ammonia, and calcium, barium, strontium. Yeah, when they meet this, they become soluble. Okay, I think we talked about lots of rules. I believe it's difficult to memorize all of them at once, but what I suggest you to do is you do more practice. I will practice some with you together in the class, but you may take the periodic table, practice by yourself, also do the problem solving section I gave to you. For example, I will print out this solubility rule to you, bring to the next class. So from that rules, I will not go back to that rules previous slide. Okay, let's see. Are these compounds soluble or not in water? This one, like I said, I like this group 1 elements. The alkali metal always form the soluble compound. This one is soluble. I don't have to look at this part. Group 1 soluble, clear. So A is up. Let's look at this one first. Ammonia always soluble. Okay, always, no exception. Now I look at here. Most of highlight are soluble, but there are 4 exceptions. The 4 exceptions including this one. So this tells us this one is insoluble. Yeah, so soluble, insoluble, soluble. How about this? If you remember the previous slide, the rule said the sulfate are soluble, except for their 7 exceptions. So that barium is one of the exceptions. That means barium sulfate is not soluble. Yeah. Most of sulfate are soluble, like the copper sulfate, like cobalt sulfate, iron sulfate. Yeah, all of them, but except for their 7. This is why soluble, insoluble, soluble, insoluble. I will choose C, soluble, insoluble, soluble, insoluble. Yeah. Let's do more practice. And for example, this is another clicker test. If you mix up the sodium chloride, okay, yeah, please now forget about these 3 we only pay attention to this yellow one. Yeah, I still keep that one because could be useful for more practice by yourself. Okay, but now we only check this one, meet 4 of them, how many cases we can have the insoluble compound. First, I will check this one meet this. You know, this is soluble, of course, and this one is also soluble because they are always group 1 alkali metal. Yeah, and so if we combine this one with this one, the sodium nitrate is also soluble because whatever, I mean, the group 1 meet others, they're always soluble. So we can forget about this. So they are definitely is soluble. Let's take a look at this one, meet this one. So if I combine this sodium with nitrate, that's still soluble because the group 1 will be soluble when it meet any ion. Yeah. Then let's look at the barium chloride. You know, most halide are soluble, but there are 4 exceptions. 4 exceptions not including barium for the chloride. That means this one, the barium ion is not an exception. This is why they will form the soluble compound. In other words, barium chloride is soluble. That's the same things like here. The copper chloride is also soluble because most of chloride are soluble. There are 4 exceptions, but not including copper, right? Okay, so that means copper is not exception. He is soluble. Yeah, copper, it formed the soluble compound, 1 meter chloride. Let's look at here. The silver chloride, there are 4 exceptions. Silver is one of them, silver mercury. Like, okay, so if this one is an exception, that means this one is soluble. It will form insoluble compound when combined with chloride. So the answer is B. Okay, so you may, you may check all of them, like what I did. For example, when I have this one, meet this one, are they going to form the soluble or insoluble compound using the solubility rules I gave to you? I think when you do some practice, you know, that will help you to memorize. Okay, I think this class, okay, it's 41 minutes. We stop here.